This ShowMe address is the second of the three methods taught in the usual American Algebra 1 course for solving systems of linear equations. The method here is called the substitution method. The first step in the substitution method is to solve one of the equations in the system for a single variable. Getting that variable by itself creates an opportunity to make a substitution. The second step is to take the expression discovered that is equal to one of the variables and use it to replace that variable that we isolated in a different equation. So if we solve one of our equations and get y equals some expression, we take that expression and use it to replace y in another equation in the system. The result is that the equation we create has no y variable in it, for that example. It only has one variable, x, and we can solve that for x. After making that substitution and creating an equation that only has one variable, we solve for the value of that remaining variable. Once we have that value, we can use it to go back and discover the value of the variable for which we originally solved. The fourth step is to take that newly discovered value and substitute it into the expression we found in step 1. Once we've done that, we'll know how to calculate the value of the variable we originally solved for. Step 5 is to do exactly that. Simplify that expression and calculate the value of the variable we solved in step 1. Finally, and always, we should take both variable values that we've discovered and check them by putting them into the equations to make sure that they actually work. Now, 6 steps might seem like a lot, but there are a couple of real advantages here. First of all, this method is simple and repetitive and easy to master. There are less variations in the way it's done. Another important distinction between this and the graphic method is that this method is not reliant on our visual abilities. Our senses don't come into play. This method is completely based on our ability to reason and calculate and solve. That makes the answer far less subject to scrutiny because human senses, of course, as I've said before, can't be trusted. Here, we're much more likely to trust our reason, and we should be. So let's try our method out here on a system of linear equations. We've got two linear equations, both in standard form. 4x minus y equals 10 and 2x plus y equals 8. We need to solve one of these equations for a variable. Now, when you first start out on this, it's important to know you get to choose which variable you wish to solve for. We could solve for x in either equation, but it's not a great idea because we're going to have fractions in the work that we do in both cases. You want to look and see if any of the variables are more easily isolated. In both of these equations, y has a coefficient of 1. The first equation has y with a coefficient of -1. The second one has y with the coefficient of 1. You'll find that when this happens, it's much, much easier to isolate that variable first. So we'll choose for step 1 to get y by itself on the right side. That's actually not very hard. All we have to do is subtract 2x from each side. So if we take 2x plus y and subtract 2x, all we have left is y. On the other side, if we take 8 and subtract 2x, we're going to have negative 2x plus 8. Of course, you could have 8 minus 2x, but in the math club, we prefer to have terms with variables go before terms without variables. So now we have a formula for y. Our second step is to take that formula for y and substitute it into the other equation. So let's draw a line here to make sure we don't get our work all confused. On the other side now, we're going to have 4x minus y. But we're not going to write y. We're going to write negative 2x plus 8. And that's going to equal 10 still. Understand we made a substitution. Y is negative 2x plus 8, Wherever we see a y, we can put in negative 2x plus 8, and so we did. There was a y here, we replaced it. The parentheses are essential. Everything about y from our formula has to be preserved, so that minus sign in front has to still be there because in the first equation, y was preceded by a coefficient of negative 1, and then the actual formula for y that we discovered was negative 2x plus 8. So both of those negatives have to be there. And to prevent confusion, we should always replace a variable when we make a substitution with a parenthetical. We should always use parentheses when we make that first substitution. Now that we've got that first substitution, it's time to clear the parentheses. Remember that if you have a negative sign in front of a set of parentheses, what you've really got is a coefficient of negative 1. Using the distributive property then, negative 1 times negative 2x is positive 2x. And negative 1 times positive 8 is negative 8. And all that, of course, is still equal to 10. Combining our like terms then, 4x plus 2x is 6x. 6x minus 8 is equal to 10. Add 8 to both sides, 6x equals 18. Divide both sides by 6, and we discover that x is equal to 3. Okay, so that was step 2, where we made our substitution, and step 3, where we solved for the value of x. Now that we have the value x, it's time to do step 4. Step 4 is to take that value of x and put it back into the equation that we discovered when we solved for y. So now we have y equals negative 2. That's supposed to be times x. Of course, now we know x is 3. Use a parenthetical again. So we have negative 2 times 3 plus 8. Order of operations says do multiplication first. Negative 2 times 3 is negative 6. Negative 6 plus 8 is positive 2. That was step 5 to calculate the value of the other variable. So now we have a possible solution, 3, 2. The sixth and final step is to check that. Well, putting them in, 4 times 3 minus 2 equals 10. Yes, it does. 4 times 3 is 12. 12 minus 2 is 10. That works. How about the other expression? 2 times 3 plus 2 equals 8. You know, 2 times 3 is 6. 6 plus 2 is 8. That works also. We do have a solution. Our solution is the ordered pair 3, 2. And that's how you solve for that ordered pair using the method of substitution. So that was how you'd handle it if you had two linear equations in standard form. What if they gave you two linear equations in slope-intercept form? Actually, that makes the whole process even easier. In both cases, we've already got solutions for y. All we have to do is replace y in one equation with the expression opposite y in the other equation. Here, we know that y could be this, y could be that. When we solve this, y has to be the same thing, x will have to be the same thing too, so we can simply set these two expressions involving x equal to each other. So we have 2x minus 1 equals x plus 1. So step 1 was completely done for us. This is step 2. From here, the left side has more x's. Let's put them all over there by subtracting x from both sides. 2x minus x is x. And then all the numbers, of course, belong on the other side. Add 1 to both sides, and you find that x equals 2. Again, all we did was subtract x from each side, and then add 1 to each side. And that's how we got the answer. Now that we know that x is 2, we can take that and plug it back in to a formula that we have for y. We have two formulas to choose from. The easiest one would be y equals x plus 1. Put the 2 in for x. 2 plus 1 is 3. So our proposed solution would be 2, 3. Well, we already know that it works in y equals x plus 1. That's where we got our solution for y. Putting them into the other equation does 3 equal 2 times 2 minus 1. Well, 2 times 2 is 4. 4 minus 1 is 3. It does work there. We already checked the other one by discovering what y was in the first place. So the solution to this system of equations using the substitution method is 2, 3. So if they give you two lines both in slope-intercept form, they've actually done you a great favor. They've done the very first step of the process for you. You should definitely favor the substitution method whenever somebody gives you two lines in slope-intercept form. In fact, I would favor the substitution method if either of the lines were given to you in slope-intercept form, and that will happen from time to time. A very popular form of word problem that uses the substitution method, that is great for the substitution method of solving systems, is a geometry problem involving the perimeter of a rectangle, like this one. The length of a rectangle is 5 centimeters more than twice the width. Its perimeter is 34 centimeters. Find its dimensions. Well, this doesn't look like a system of linear equations at first blush, but let's try to write down what it actually says in algebraic terms. The length of a rectangle is 5 centimeters more than twice the width. Well, we don't know what the length or the width are, so both of those suggest variables. Let's use a cursive L for the length. It said the length is, that would be equals 5 centimeters more than twice the width. That would be 5 plus 2, and then we'll use W for width. So the first sentence corresponds to this equation. Length is 5 more than twice width. Its perimeter is 34 centimeters. Now, the perimeter of a rectangle is twice its length plus twice its width. And it says here that that is equal to 34 centimeters. Now we clearly do have two linear equations in two variables. Even more conveniently, the very first sentence gave us the first step of the substitution method. Length is. It's already solved for length. Immediately we can go on to step 2, and in the second equation we can replace the L with the expression for L, 5 plus 2W, and then write the rest of the equation and solve it for W. The distributive property applies here. 2 times 5 is 10, and 2 times 2W is 4W. You still have plus 2W equals 34. Combine like terms, 4W plus 2W is 6W, and subtract 10 from each side. 34 minus 10 is 24. Divide both sides by 6, and we discover that W is equal to 6. So we now have one of our variables. That's the end of the third step, solving for one of the variables. The fourth step is to take that value and put it into the formula we discovered. Well, we only had to discover this formula by reading the problem, but the length now should be equal to 5 plus 2 times 6. Doing multiplication first, according to the order of operations, 2 times 6 is 12, 12 plus 5 is 17. Well, it took me that long to figure out that I made a mistake. I'm sure you figured it out much sooner. In any case, the width isn't 6. The width is 4. 24 divided by 6 is 4. Then take the 4 and put it back into the formula. Length equals 5 plus 2 times 4. 2 times 4 is 8. 8 plus 5 is 13. The sixth and final step is to take the two values we've got, 4 for width and 13 for length, and plug them into both equations to make sure we've got it right. Well, we got 13 from the first equation, so we know that that part's going to agree. The other one, 2 times 13 plus 2 times 4 needs to be equal to 34. Now 2 times 13 is 26, 2 times 4 is 8, and 26 plus 8 is 34. So both of our equations do check out. Our solution is that the width of this rectangle is 4 centimeters, and the length of this rectangle is 13 centimeters. This is a very popular variety of word problem on standardized tests. You'll almost always see one or two on the SAT and ACT, and certainly on the state assessments in our state. Just remember the process and you should be fine. First step, solve for a variable. Second step, make a substitution. Using the formula you discovered in step 1, make sure you make your substitution into an equation other than the one you used to find that formula. If you put it back into the one you used, you'll get a statement that can't ever be false and won't give you any valuable information. After you've made your substitution, solve for a variable's value. Now in the first step when you're solving, you're just solving for a formula. But in step 3, you're actually solving for part of the answer. So it's a little bit different. Step 4, substitute that value into the formula you discovered in step 1. And then use that formula in step 5 to calculate the other variable's value. Finally, in step 6, as always, check your answer. Make sure that the point you've chosen actually satisfies both equations. You follow that process, you should be able to master the art of solving systems of linear equations in 2 variables using the substitution method.